It just gives me a message that it's not recording audio. I think it's okay now. Okay. Factoring, simplification, rationalizing. And we will have other methods, like L'Hopital's rule. It's L apostrophe L'Hopital apostrophe S rule, which we're not ready for, and other methods. But there is one particular situation or theorem called squeezing, which works in certain situations. And here is the premise of the theorem. Let's suppose I have a function that is f of x. Let's suppose I have another function that, let's say, is g of x. And let's suppose I have a function that does whatever, but is squeezed here, and then it does whatever, and I'm going to call that h of x. So all this action happens near A. So the squeezing theorem has two hypotheses. Hypothesis number one, based on this graph, can I say that near A, I'm not talking about here or here, I'm talking about here, near A, can I write that g of x is less than or equal to h of x, which in turn is less than or equal to f of x? Anyone?
Yeah, because they're stacked like that.
Correct.
Yeah.
In other words, they're squeezed. So this is f, this is g, and right here in between is h. Okay. Number two, would you agree that the limit of f of x as x approaches a equals the limit of g of x as x approaches a? And I'm going to give it, because they exist and they're equal, I'm going to say L. A number. Any number, but a number, not infinity, not something that I cannot tell you. It's secret. Then, what do you think about limit of h of x as x approaches a? What will that equal to?
That should be L as well, right?
That's it. By the squeeze, theorem. By the squeeze theorem. And here's an example for you. So let's look at limit of x to the fourth times cosine 2 over x as x approaches 0. And let's see what this equals to. Let's say this is an x approaches 0 from the right. Okay. What do we do first? And any suggestions?
Plug in.
Correct. Very good. Where does this go?
0.
Very good. So see, this is the inner function and this is the outer function. So this is a function composition. Outer, this is a product, and inner. First, I have to plug in the inner. 2 over 0 from the right We know the graph of 2 over 0 because we know the graph of 1 over x. 1 over x or 2 over x, same thing. So where does the inner go?
0.
The graph of 1 over x.
Infinity.
Very good. And what about cosine infinity? It's oscillating. I have no idea. So you could say, oh, 0 times d and e is 0. Not so fast. So there is something called, we're going to talk about them a lot, indeterminate cases. There's 7. 7 indeterminate cases. I'm not talking about undefined. I'm not talking about undefined. Undefined situation is a number divided by 0. I shouldn't cross it out. That's what undefined means. A number not 0. Not 0 over 0. That's undefined. But 7 indeterminate cases that we're going to see in this class, one of them is, for example, 0 times infinity. There is no guarantee that this is 0. Another one is infinity minus infinity. Nobody knows. It's an indeterminate case. Nobody knows what that equals to. Another one is infinity raised to 0. Nobody knows what that is. Another one is 0 divided by 0. No one knows what that means. How come? Look at this one. This was 0 over 0. And we got 3 over 7. Would you have known that 0 over 0 turns into 3 over 7? No. You wouldn't have. Infinity over infinity. Okay? And we're going to add 2 more later. So coming back to our problem, limit of x to the 4th times cosine 2 over x. Can I write it as limit of x to the 4th when x approaches 0 from the right times limit of 2 of course cosine. Sorry, I always run out of room. So just this is cosine here of 2 over x when x approaches 0 from the right. Can I do this? Jordan?
Yes. Or no, because one of them is infinity.
Very good. Limit law is not applicable here. Excellent. Great job. Okay, so this is a typical situation in which we will use the squeeze theorem. But it has 2 parts. If I don't show this, and if I don't show this, I cannot conclude this. So first I have to focus on this first part, first hypothesis. So let's focus on that. So this is our function f of x. It's basically a product of 2 functions. I will start with cosine. So cosine 2 over x. What do we know about cosine? I said that last time. I don't know if I have it. I already put it in my recycle bin. Here it is. What do we know about cosine? A nice function, really nice. What did we say last time?
It has to be in between -1 and 1.
That's it. That's my starting point. Good. So I'm building this f of x. I have a portion already. So I want to build it inside here so that I can also have these 2 functions. What do you think we need to do to all three sides to get this function in the middle? Trey, what do you think? Trey, are you with us?
I'm not sure.
Okay. Ian,
Not,
say it again.
not exactly sure either.
Okay. Who would like to give it a shot? It's okay, don't be afraid.
Mark, how would you multiply by x to the power 4?
Of course. We will multiply all three sides by x to the fourth. However, I have to check two things. I have to make sure that this is always positive and it's never 0. How come? Why can't I multiply both sides, all three sides by 0? How come that I cannot multiply by a negative number? I can. But when I multiply an inequality by a negative number, what do I need to do? Gia? Yes, flip the symbol. And how come that I cannot multiply all three sides by 0? What's the big deal?
Because then they're all 0.
Of course. So is this quantity not 0? It's not, because when x approaches 0, even from either side, it's still not 0. Is this quantity always positive?
Yeah, because it's a positive, or it's an even.
Exactly. So both conditions are fulfilled. So I'm going to go ahead. Can anyone tell us what we get? Anyone? Gia, would you like to try?
Will it be x to the 4? Well, negative x to the 4. And then in the middle will be x to the 4th times cosine 2 over x. So it'll look like what we started with. And then it'll be x to the 4th.
Excellent. Great job. So the first condition is done. Now I have to check the second hypothesis. Good. So this first step is awesome. And
I have a
now,
question.
yes?
So in order to know if we're doing this the right way, the middle, like where h of x will be, should that look like what we started out with, our function?
It has to be identical,
Okay.
not just resemble. Otherwise, we cannot conclude. We are not determining the limit. Very good. So the next step is I have to find the limit of negative x to the 4th, which is our f of x and g of x, or vice versa, it doesn't matter. As x approaches 0 from the right, I have to find the limit as x approaches 0 from the right from x to the 4th. Let's say, Javon, will you give us these two? Javon, are you with us?
Sorry, I was muted.
That's okay.
Wouldn't it just be 0?
Of course. Great job. So this is number 1, and this is number 2. Therefore, sorry, I didn't mean to write that. From 1 and 2 by the Squeeze Theorem, we conclude that, can anyone give us the conclusion?
The limit of as x approaches 0 from the right is 0.
Very good. Not of x, but x to the 4th cosine Did you say h or did you say just x?
Of the entire function.
That's excellent. Great job. So limit of x to the fourth cosine 2 over x as x approaches 0 from the right is 0. And yes, I'm sure you're thinking, I would have known that from the very beginning. 0 times whatever is 0. No, no. 0 times whatever is not 0. It could be, but it's not always. Okay, I like to look at a problem with absolute value. We need to do that, very important. So feel free to choose if you'd like to choose, or I will. So I'm looking at 43, 44, 45, 46, 47, 48. Please choose one with absolute value. And that completes section 2.3, and we can move on to 2.4. All work from 2.1 through 2.3 has to be finished by Tuesday. You have to finish it because if you don't, you're not going to ask questions. We're going to fall behind, and we're not going to be able to finish before. Obviously, I fell behind tremendously already, so I have to push the first test down the road. But we have to finish this. For full credit, you must finish by Tuesday. Thank you. Okay, are you choosing, or am I choosing?
47.
47, let's do 48, and you do 47 because you have the answer. It says in there. So let's do 48. Is that okay?
Yes.
Okay, perfect. It's the same function. So limit as x approaches 0 from the right, 1 over x minus 1 over the absolute value of x. Perfect. I will stop sharing. Okay, so please pay attention to this because for some reason, sometimes it sounds or it looks difficult. I'm not sure why. Okay, so where is our starting point? Kush, what do you think? Where is our starting point?
Factor.
There is nothing I can factor here. Yen? Josh?
We plug in 0.
Good.
Correct.
And I'm not getting anywhere because I cannot use the limit law. This does not exist. This does not exist. Infinity, infinity, I don't care. So then it's a perfect step, yes. Then what do you think we have to do? Anyone?
Make the denominators the same?
Good point, but we can't because we cannot do anything here. Anyone else? Okay. Yes, go ahead.
Oh, I was just going to guess the squeeze theorem, but
No. No, the squeeze theorem, it's a very good point. Squeeze theorem is normally in a product like this, normally, in a product of two functions. And most of the time, we have a cosine or sine in there. Most of the time.
Okay.
No, the starting point is with the absolute value of x. So the starting point is must, and you'll have to do this, please, must fully simplify the function without absolute value. That's our starting point. Crucial here. Okay, so this is where we have to start. So let's start with the absolute value. Can anyone give us the definition? It was discussed, it appears, a long time ago.
The
Yes,
distance from 0?
correct. But the formal definition is, yep, formal definition.